So in this video, we are going to see what is a stack and various operations on stacks and algorithms and their applications. So here see what is a stack. A stack is a linear data structure and a stack is a ordered collection of items into which a new items may be inserted in from and new items may be deleted from only one and called a top. So generally stack works under a principle called last in first out, LIFO or LIFO. And you can see various examples on stacks like in a real life. So those are desk of cards, pile of books, and files of money and papers at the printer. So all these are the examples of the stacks. So the main principle of the stack is whatever the element or whatever the data we are inserted into the stack recently, that will be removed first. So in this example also, if we have a file of cards or a file of books, then you can see only the top book first. After that you can take the next book. After that you can take the next book, but at a time you can't take the book at the bottom. So generally the stacks can be implemented either using arrays or linked list. In this we are going to see the implementation of stacks using arrays. So initially the stack is empty, the empty condition can be shown with top equal to -1, and here the stack is implemented with arrays, and here we're using one pointer called a top, or top is always pointing to the top element of the index, and the empty stack can be represented with top equal to -1, and the full stack is represented with top equal to max -1, and where the max is the size of the array. So initially you can see the array is empty. You can call this as a empty stack, and there is only one end called top, so from which we can insert and delete the elements. So here we can see the sum of the elements present in a stack, and there is a pointer called top, top always pointing to the top element in the stack. And various operations we can perform on stacks: push operation, pop operation, size, is empty, is full, and peak. See what are the operations in detail. So push operation means adds an element into a stack. And pop operation means removes an element from the stack. And size is always tells you the number of elements present in the stack. Is empty returns whenever the stack is empty, and is full returns true whenever the stack is full. Peak always returns the top element from the stack, but element will not be deleted from the stack. So here you can see push and pop operations, how those two are going to happen in stacks. So first one is the stack is empty. So if we insert element 1, then the element 1 will be on the top of the stack, and after that you can insert element 2, that will be placed at the top of the 1. So now the top is pointing to the top element in the stack, that is 2, and the next we can push a third element 3 onto the stack, and we can see that 3 on the top of the stack, and next we can insert element 4, and you can see 4 on the top of the stack, and we can remove the and 5 also pushed, and you can remove the only top element first. Top element 5 is removed first, after that 4 will be removed, 3 will be removed, 1 will be removed. So after removing 1, the stack is empty. So see what is the push operation and what are the conditions we have to check, and how can we insert an element everything into how can we insert an element into the stack. So push operation. So first for pushing an element into a stack, first we have to check the overflow condition of the stack. So the overflow condition is top equal to max -1, where max is the size of the array. So if top equal to max -1, then now the stack is in overflow condition, then you have to just display the stack overflow condition, print overflow, otherwise go to step 4. So in first we have to for inserting a new element into a stack, first we have to increment the top by 1, then you will get one location. In that location is called as a top. In the top we have to place the element. So that statement can be like stack of top equal to value. So value are the element. Here stack is an array and top is the index of the top element in the stack, and the value is the element which we want to insert. And the second operation is called as a pop operation. For popping an element from the stack, we have to check underflow condition. So the stack underflow condition is a top equal to null, means there are no elements in the stack. So if there are no elements, then we can't delete an element from the stack. So first we have to check the underflow condition for deleting an element. So that underflow condition is top equal to null or the -1, print underflow, otherwise go to step 4. So here we have to take that value or the element which is on the top, that is stack of top, assign that to one value, and after assigning the value and after removing the top value from the stack, just decrement top equal to top by 1, that is top equal to top -1. And peak operation, so peak operation always returns the top element from the stack, but it will not delete any element from the stack. So for peak operation also we have to check a stack empty condition. So if there are no elements, then we can't show or we can't take the elements from the stack. That's why we have to check the overflow condition, the top equal to null, print stop underflow condition, then top equal to null, then print stack is empty, otherwise return the element which is on the top with a statement called stack of top. And the next one is size operation. Size will always returns you the number of elements present in the stack. For that also we have to check the empty condition. If the stack is empty, then we can't find the size. So the stack empty condition is top equal to null, then the stack is empty. Otherwise take the top plus 1, that will gives you the number of elements present in the stack or the size of the stack. And useful operation, so useful operation returns true if the stack is full, otherwise it returns a false. So for checking a stack full condition, we have to check the top value. If the top value is max -1, then our useful operation should return say true, otherwise it returns a false. And next operation is isEmpty operation. So isEmpty operation checks the stack underflow or the empty condition. So if the stack is empty, then it returns true, otherwise it will return false. So the stack empty condition is top equal to null or a -1. If it is empty, top equal to -1, then return true, otherwise return false. And we have various applications of the stack. So applications are like depth first search and function call execution mechanism, and recursive function calls execution, and parsing, syntax analysis, and compiler uses stacks in parsing a program. And web browsers also stores the addresses of recently visited sites on the stack. Undo mechanism in the editor also uses the stack. Reversing a list, first to push all the elements of the string in a stack, then pop the elements. Expression conversion, infix to postfix conversion and postfix evaluation, and infix to prefix conversion and prefix to infix expression, and prefix to post